Suppose you have 3 points and there's a plane passing through it. Now, one of the things that you need to figure out in order to write down the equation of the plane is the normal vector, right? So the question is, what's the normal vector to this plane? So here's how you think about it. So suppose you have 3 points in space, and these 3 points will form a triangle, right? And then you're going to get a plane that will contain this triangle fully, and therefore you get a unique plane, and that's going to have what we call normal vector. Normal vector means it's a perpendicular vector, right? So it's perpendicular to every vector that's on this plane. So it's like this. It's perpendicular to this vector, and it's also perpendicular to this vector. Okay. And it's asking us to find the perpendicular vector in this form as something with -10. The reason they give you one answer is because there are many different perpendicular normal vectors. There's like a short one and there's a long one. There's even something going the opposite direction. So unless you're given one coordinate, it's impossible to come up with a unique answer. Of course, if the question was just finding the equation of the plane, you can use any of the normal vectors. You can use any normal vector, and if you have, say, your normal vector is ABC, then the equation of the plane would be ax minus x1, bx minus y1, plus c z minus z1 equals to 0. That's the equation of the plane where a comma b comma c is a normal vector. Well, that's for the next section. Just to answer this question, what do we do? Well, see, since this vector has to be perpendicular to any of these vectors, let's just call this A, B, and C, and let's say these points are A, B, C. Then this vector has to be perpendicular to vector AB and also AC. So let's look at vector AB and AC. So what is vector AB? AB is B minus A. It's always terminal minus initial, so it's -1, 1, -4 minus the initial -4, -2, 0, which is 5, 3, and -4. Okay, so that's the vector AB. AC, you do the same thing. It's terminal minus initial, so -1, 2, -2, minus -4, -2, 0. Then it's +3, 2 minus -2, that's 4, -2 minus 0, so it's 0. No, 2, -2. Okay, so you have these two vectors. And actually there are two ways to solve this. One way is to use the fact that if these vectors are perpendicular to this vector, their dot product is 0. Okay, so let's just say that the vector is -10 comma x comma y, and do a dot product with 5, 3, -4, and this has to be 0. What does that mean? That means negative times 5, -50, x times 3, so 3x, and then -4y has to be 0, and -10 xy has to be perpendicular to this other vector, 3, 4, -2, and that has to be 0 because these should be perpendicular, so -30 plus 4x minus 2y has to be 0. Okay. Now I think I can just simply solve this for y. So move the 2y to the other side and divide by 2, and I get y equals to 2x minus 15. Plug that back in here, and then I can get an equation for x. -50 plus 3x minus -4 times 2 is -8x, right? And then -4 times -15 is plus 60. equal to 0. So negative 5x plus 10 equals to 0. So x must be 2. If x is 2, plug that back in here. I get 4 minus 15, negative 11. So I get 2 for x and negative 11. Okay, so for this question, I think it's easier to just use the dot product. But, you know, when it comes to finding the equation of a plane, usually you're not given this first coordinate. And I would say that usually the cross products are better. So let me show you how to do the same thing with the cross product. So, yeah, I shouldn't have erased A, B, and AC. So let's copy that down. 5, 3, negative 4. AB is 5, 3, negative 4. AC is 3, 4, negative 2. Okay, and then AB cross AC. What does a cross product do? If you have two vectors, AC and AB, then AB cross AC gives you this vector perpendicular to both of them, and the magnitude of this vector is same as the area of this parallelogram given by the two vectors, right? So because of that, this is a convenient way to come up with just one vector that's perpendicular to both. It's quicker. I, J, K, 5, 3, negative 4, 3, 4, negative 2. Do the expansion, so it's plus I, 3, negative 4, 4, negative 2, minus J, 5, negative 4, 3, negative 2. See, if you choose J, then cross out the row and the column. The numbers that are left are 5, negative 4, 3, and negative 2, right? Then plus K, 5, 3, 3, 4. That gives you negative 6 plus 4, so it's 2I. And then this gives you negative 10 minus plus 12, so it's negative 2J. And then K would be 1. No, 5 times 4 is 20 minus 9, so that will be 11K. Okay. Oh, now I'm a little nervous because the answers don't seem to match. Oh, okay, so maybe I think what I must have done wrong is this one. Oh, yeah. So this 3 times negative is negative 6. This is plus 16, so this should have been positive 10. Okay, so here's what we got. We got this vector, 10, negative 2, positive 11, right? And how do you get a vector that starts with negative 10 and it's perpendicular to both? Well, if you have any other vector that's perpendicular to this one, these two vectors will be like either in the same direction or direct opposite. So in other words, the two vectors, because they're parallel to the same set of vectors or same plane, they will be so if you have two vectors that are perpendicular to the same plane, these two vectors will be parallel. So we know that these two vectors are multiples of each other. So I know that this is equal to this vector times something. So I know that this is equal to some k times 10. K is some number, it's not this k hat. K hat is the vector, but k has nothing to do with k hat. Let's just say k is some number, and k times 10 times negative 2 times 11. So what should k be for this to match negative 10? K times 10 is negative 10, so k must be negative 1. So we get that the answer is negative 1 multiplied, we get negative 10, positive 2, negative 11. Okay, so that's the answer. That's how you get this. So actually that may have been actually easier than the dot product. Okay, so choose whatever method, but I would suggest that in general, for finding perpendicular vectors to two vectors, cross products is much a better deal. Okay. Here's another question. Let's say you're given these, and the question is to find the angle between the two things. Now, what you have to be careful is that this is not a multiplication, it's a cross product. So you have to know that the cross product has the meaning that it's a vector that's perpendicular to both vectors, but its magnitude is the norm of each times the sine of the angle between. Okay, and this has the geometric meaning that it's the area of the parallelogram. So if you have a V and W, this area is calculated by this formula. Okay, so the cross product V cross W is a vector given by the right-hand rule that's perpendicular to both, and this, the magnitude of this is same as this calculation, the area of this. Okay. All right, so that's what we know. So when I see this, don't think of this as V times W being 3. It's really V norm, W norm times sine theta equal to 3. Now, what about V dot W equals to 4? Well, V dot W, this by definition is the norm of V times norm of W times cosine of theta, and that has to equals to 4. Okay, so these two conditions are actually what these two conditions mean. Now, look at these closely. It's asking for tangent. How do you get tangent? Well, interestingly, if we divide the two, then these two cancel and you get sine over cosine, which is tangent of theta. But what is this value? We know that this is 3 and this is 4, so I know that this value is same as 3 over 4. So we know that the answer to this is 3 over 4, and therefore theta will be tangent inverse of 3 over 4. Okay? Now, there is something that you have to be careful a little bit. Angle between two vectors are always between 0 degrees to 180 degrees, right? So tangent would be positive between 0 to 90 degrees. We know that tangent graph is like that. So before 90 degrees it's positive, but after 90 degrees tangent becomes negative. Between 90 degrees to 180 it's negative. So if in some cases the dot product might be negative and this could be positive, and you might end up with tangent being negative, then you can't write the answer as simply as tangent inverse of that value, because the tangent inverse of a minus number gives you an angle between negative 90 to positive negative 90 to 0 degrees. So so maybe I should just put a note here. Note, if tangent theta is less than 0, then theta would be, you take the value of the tangent theta that you're given, but you have to add 180 degrees, because this value would be between negative 90 to positive 0, not positive 0, negative 90 to 0. So adding 180 degrees will make it to be an angle between 90 to 180 degrees, matching what we think it should be. Okay?